So today we're going to talk about inverse trig functions, and we've talked about inverse functions earlier in the year. An inverse function is basically going to undo what a trig function does, or in this case we're going to work backwards. So I wrote going backwards. We're going to try and find the inverse. There are two different ways that you'll see inverse questions written. One is arc cosine, the other is cosine to the -1. These both mean the same thing, and they mean inverse cosine. So to the -1 means inverse, and arc means inverse when you're talking about trig functions. So this question is saying, what is the inverse cosine of square root 2 divided by 2? Both of these are the same question, so we'll just we'll answer one of them. And what you do when you're doing a trig inverse is you will go to your unit circle, and instead of going to the angle and getting the cosine, you already know the answer. So if I know the answer is square root of 2 over 2, I have to look around the unit circle, find when cosine is square root of 2 over 2, which cosine's x, so it's right there, and the answer would be the angle that gives you that answer. So the answer here would be pi over 4. Actually happens twice. It happens here and here. So 7 pi over 4. We are going to end up only writing one of those, and I'll talk about how we know which one is correct in a second. But to summarize, when you're doing an arc cosine, which is cosine inverse, you will look around the unit circle at the x values, because cosine is an x value, until you find the one you're given, and then you write down the angle. Now, the deal with inverse functions is there is actually an infinite amount of possibilities that this could be, because the circle is infinite. You could go around again and say, 9 pi over 4, or 15 pi over 4, or any of the coterminal names for those two angles. So what we want to do is try and narrow that down by picking a range that we have to stay in. So that's what this box is for. This says when you do an arc cosine question, your answer has to be between 0 and pi. So pi over 4 is between 0 and pi. This one's good. 7 pi over 4 is too big, so that one is going to be outside of the range. Whenever you do cosines, your answer will have to be in there, which means for cosine, when you look at your unit circle, you're only going to look in the top half. So when you do a cosine inverse question, you only look between 0 and pi. The arc sine and the arc tangent are the same, but they are different than cosine, so I'm going to write that over here. So arc sine and arc tangent are between negative pi over 2, which would be right here, and positive pi over 2. So they are only looking on the right-hand side of the circle to get sine inverse and tangent inverse questions. Or answers, I guess. So let's try a couple here. We have a sine inverse question, which is sine inverse of a half. And so we'll go, and again, with sine inverse, we only look on the right side of the circle. And we look at, because sine is a y value, we look at all the y values until we find one that's half. And that's half. So I write down the angle, which is pi over 6. Here we have inverse cosine. Cosine, we look at the top half of the circle. I go here, cosine is x, so I look at all of the x values in the top half of the circle until I find an x value that's 0, and then I write down that angle. Last is arc tan is 1. Tangent's a little bit harder because you would have to take the y value divided by the x value until you get 1. So is 0 divided by 1, 1? Nope. Is half divided by square root of 3 over 2, 1? Nope. Is square root of 2 over 2 divided by square root of 2 over 2, 1? Yep, because they're the same. So for arctan, I was only looking on this half of the circle, and I found it here because this divided by this would be 1. So that would be pi over 4.